All right, let's dive right into this explainer. Today, we're unpacking a highly complex, honestly fascinating paradox about a molecule you probably thought you had totally figured out. Look, when I say the word histamine, I'm willing to bet the very first thing that pops into your head is a runny nose, maybe itchy eyes during pollen season, and, a quick trip to the pharmacy for allergy pills. But what if I told you that this single molecule does so much more than just make you sneeze? It's actually a master regulator of your brain, your gut, and your entire immune system. Welcome to the histamine paradox.
To really wrap our heads around this, we actually need to ask the exact same questions that inspired the original researchers in this field. Think about it for a second. We all know the feeling, right? You inhale some dust, you take a first-generation allergy pill like Benadryl, and then boom, you're hit with this overwhelming wave of exhaustion. Why on earth does a drug meant to just dry up a simple runny nose cross the blood-brain barrier and practically knock you unconscious? This paradoxical side effect completely puzzled early scientists. I mean, it was a huge clue. It strongly hinted that histamine wasn't just, hanging out on our nasal passages. It was doing something massive inside the human brain.
And that realization brings us to the next brilliantly weird scientific mystery, the one that forced pharmacologists to look way beyond the sneeze. Okay, so if histamine is the universal chemical for inflammation, why did those early antihistamines completely fail to stop stomach inflammation and ulcers? Patients taking allergy meds were still suffering from severe gastric issues. The math just wasn't adding up. This was the exact contradiction that forced researchers to realize histamine was basically speaking different languages in different parts of the body, using a completely different set of cellular receivers. Which brings us to Section 1, the 4-receptor mystery. Now, take a look at how bizarrely spread out these domains are across the 4 histamine receptors, known as H1 through H4. It's like a giant puzzle. H1 is your classic allergy receptor, right? It's found in smooth muscle and the brain, controlling both bronchoconstriction and, crucially, our wakefulness. Then you've got H2, which was discovered a bit later. That one is heavily concentrated in the stomach lining to trigger gastric acid, and, surprisingly, in the heart, where it directly affects your heart rate. Then we dive deep into the brain with H3 and finally H4, which is a relatively recent discovery located in the bone marrow, basically acting as a homing beacon for your immune cells. Let's zero in on the brain for a second. As this quote points out, histamine is actually a highly conserved monoamine neuromodulator. It originates from this tiny little cluster of neurons in the hypothalamus called the tuberomammillary nucleus. Now, these neurons are what we call wake active. They fire super rapidly when you're awake and go completely, totally silent during deep REM sleep. So the big aha moment here, those first-generation antihistamines we talked about, they readily cross the blood-brain barrier, bind to the H1 receptors in your brain, and totally suppress that excitatory tone. You are literally blocking the exact chemical that's actively trying to keep you awake. But wait, the brain's relationship with histamine goes even deeper, thanks to the H3 receptor. Unlike H1, which just receives signals, H3 acts more like a presynaptic monitor. It sits right on the nerve terminals and regulates exactly how much histamine is being released, creating this absolutely vital negative feedback loop. But it doesn't stop there, and this is wild. It also modulates the release of other heavy-hitting neurotransmitters, like dopamine, serotonin, and acetylcholine. The discovery of the H3 receptor was a real game-changer. It revealed histamine as this profound neuromodulator that maintains the delicate overall chemical balance of your entire brain. Moving right along to Section 2, the brain's chemical bouncers. So, with a molecule this powerful, something influencing everything from stomach acid to serotonin, your body absolutely needs a highly efficient way to clean it up. You can't just have it running wild. The body needs a way to destroy it the literal second the job is done. Enter the 2 molecular bouncers, DAO and HNMT. DAO, or diamine oxidase, functions outside of your cells, mostly in your gut. Think of it as the bouncer at the front door of a club, destroying histamine from aged cheeses or fermented foods before it can ever enter your bloodstream. HNMT, on the other hand, works inside the cells, especially in the liver and the central nervous system. It is your internal off switch, deactivating neural histamine so your brain circuits don't completely short out from overstimulation. Which, naturally, leads us to ask, what happens if your biological bouncers, fall asleep on the job? What if you have genetic variants or even just nutrient deficiencies that make DAO and HNMT sluggish? Well, histamine starts to pool and accumulate. And what happens when this lingering histamine interacts with a highly sensitive, highly adaptable nervous system? Let's explore that in Section 3, the hyperneuroplastic system. This is where the medical mysteries get truly mind-blowing. Let's look at how histamine behaves in people with unusually adaptable nervous systems, a concept known as hyperneuroplasticity. Basically, this is an unusually high capacity for the brain and body to rapidly and deeply reconfigure itself based on whatever stimuli it's getting. We see this a lot in neurodivergent profiles, like giftedness, autism, or ADHD, or just in folks with highly responsive autonomic nervous systems. In these systems, the crosstalk between the immune system and the brain is intense. The histamine signaling is massively amplified. And while, yeah, that can heighten sensory focus and memory, it also drastically spikes the risk of hyperarousal and complete sensory overload. This perfectly highlights this bizarre circadian rhythm trap that hyperneuroplastic individuals often fall into. Okay, step 1. Histamine naturally surges in the early morning. It's your biological alarm clock, totally normal. But step 2, if your HNMT or DO enzymes are sluggish, breaking that histamine down gets delayed. So, step 3 happens. The wakefulness signal totally overshoots. Instead of just waking up feeling, refreshed and ready to go, the nervous system registers this massive, lingering chemical load as a direct threat. A perfectly normal morning wake-up call misfires into profound morning anxiety, a racing heart, and just this intense physical restlessness. Section 4. Intolerance and system misfires. Let's zoom out and look at the broader clinical reality when this whole systemic web gets tangled up. When histamine isn't cleared out properly, or if immune cells are misfiring, we cross over into the territory of histamine intolerance and mast cell activation syndrome. Just look at how incredibly diverse these symptoms are. We're talking everything from a standard runny nose to a racing heart, insomnia, severe bloating, hives, and even getting super dizzy when you stand up. Because histamine receptors are quite literally everywhere, a systemic buildup doesn't just give you the sniffles, it causes systemic chaos. It can literally mimic everything from a full-blown panic attack to a severe stomach bug. So what's the big takeaway here? Histamine is the ultimate integrator. A spike in your immune system's histamine doesn't stay in your immune system. It ripples right through your nervous system, your heart, your gut. It's like a biological domino effect. It even tangles with your endocrine system. For example, the female hormone estrogen actually increases histamine release while simultaneously lowering DAO activity. Progesterone, on the other hand, stabilizes it, which beautifully and, let's be honest, very frustratingly, explains why some people experience these intense cyclical swings in their anxiety, their sleep quality, or their digestion right in rhythm with their hormonal cycles. Finally, Section 5, Taming the Master Key. The good news? Science absolutely offers ways to hack this complex biochemical web. By understanding the specific receptors and those bouncer enzymes, we can actually start to tame this master key. But managing a dysregulated histamine system requires a really integrated strategy. It is not just about popping a Benadryl and calling it a day. It involves utilizing targeted pharmacological H1 and H2 blockers. It means nutritional optimization, giving your gut bouncers the actual raw materials they need to work, like vitamin C, B6, and zinc. It involves using natural flavonoids like quercetin to stabilize mast cells. And maybe most importantly, it requires lifestyle pacing and actual nervous system regulation to calm down that hyperneuroplastic crosstalk. We'll leave you with this final, somewhat wild thought. This single, tiny molecule connects a speck of dust, the acid in your stomach, your ability to pay attention, and the anxiety you might feel at 6 a.m. It's all connected. So next time you sneeze, just ponder that for a second. Is your body simply fighting off a little allergen, or is your entire neurological web responding, adapting, and fundamentally rewriting itself? Thanks for exploring the depths of this fascinating paradox with me on today's Explainer. Keep questioning the simple answers and keep learning.